Welcome, Mr. Ertug.
Thanks.
In the last episode, we discussed many topics, from raw material quality to zero-line technology, and from colour matching to practical tips. In this episode, we will examine bonding methods in detail. Now, just like in our previous video, let's continue with the first question. There are many bonding methods. We discussed the pros and cons of EVA and PUR glue systems. Besides these, glue-free systems are also gaining attention. If we were to make a comparison, what are your thoughts on this?
In glue-free systems, laser, near-infrared, and hot air systems actually work on the same principle. Instead of using external glue, you use energy to activate the co-extruded functional layer on the back of the edge band. Since there is no external glue line here, a polymer-to-polymer interface fusion occurs, and the result is this: a visually flawless and superior, invisible joint. Since there is no glue pot, there are no limitations such as open time. Well, this technology has now become standard in European furniture production. It is also spreading rapidly in export markets. Laser and near-infrared systems require high initial costs. But look, the hot air system is a bit more accessible. It works with zero-line compatibility. The line speed remains a bit lower. There is also plasma. It works perfectly, especially for polypropylene edge banding, and it is an eco-friendly method. What is critical here is increasing the surface energy and obtaining an active surface suitable for bonding.
So to summarize, EVA is economical but sensitive. PUR is strong but requires maintenance. Glue-free systems are the peak of quality but require investment. Well, what are the most critical process parameters that determine bonding quality?
It wouldn't be right to look at just one parameter here. It depends on the combination of temperature, pressing pressure, line speed, surface quality, and the back layer structure of edge banding. For example, if the temperature is not sufficient, activation isn't completed, and if it is too high, deformations may occur in the material structure. Similarly, when the pressing pressure is low, bonding does not fit properly, and when it is too high, surface may be distorted. That is why we do not just check if it's stuck or not. We evaluate the entire process, because even the best product will not perform as expected at the wrong temperature, wrong pressure, or unsuitable line speed. In other words, a strong result is achieved as much by proper setting discipline as it is by the right material.
When customers face bonding issues, they usually blame the machine or the edge band. As R&D, what do you look for when performing a failure analysis? Which errors do you see most often?
Actually, every delamination case has its own unique story. First, we determine this. At what stage does the problem occur? If it happens immediately, meaning the tape opens as soon as it leaves the machine, this usually means insufficient pressure or low temperature. But if the problem appears a few days later, especially after the customer receives the product, then it is different. We usually see chipboard or MDF surface contamination, moisture issues, or wrong glue selection. For example, banding MDF panels right after production is a classic mistake. The moisture inside the MDF has not yet stabilized. The glue seems to stick, but a week later, the panel shrinks and the tape peels off. Another common issue is surface dust. Especially with panels from CNC cutting, chip and dust buildup directly affects adhesion. Even simple vacuum cleaning can eliminate many problems. We tell our customers this: adhesion is a system. The edge band, glue, machine settings, panel quality, and even the ambient temperature. They all have to work together. If one fails, the chain breaks. That is why you must look at problem-solving systematically.
Customers sometimes say the same product gives different results on different machines. What could be the reason for this?
This is quite common and usually depends more on process conditions than the product itself. Each machine has different heat transfer, pressure, preheating, and tolerance. So a product that works well on one line may not perform the same on another, because the application dynamics change, so product selection must consider both the material type and the machine's technical character. That is exactly why we test on different lines in R&D. Our goal is to optimize the product not for one ideal condition, but for real field conditions. This way, whatever machine the customer uses, they get a more stable and predictable result.
So what should customers look for when choosing a product, in your opinion?
The most critical point is choosing product according to the machine. Every bonding method has a different dynamic. EVA, PUR, or zero line all require different backing and thickness structures. Each method has its own surface chemistry. That is why the correct machine type must be shared when placing an order. We then recommend the most suitable product accordingly. When the right product is combined with the right process, quality comes naturally.
Looking to the future, in which direction are we heading in edge banding technology?
Absolutely. Glue-free systems will become more common. Environmental pressure is increasing, and consumers want higher quality, more durable products. Our role is to support our customers through this transition. We must produce solutions for both traditional workshops using EVA hot melt glue and large factories investing in state-of-the-art hot air glue systems, and we do this in our R&D center with our R&D power. The future will definitely belong to lower emission, sustainable and functional polymers, better quality.
Ertug, this has been a truly comprehensive interview. We covered both technical details and shared practical information applicable in the field. Thank you very much.
Thank you.